Okay, let's start with quite literally a high altitude view using the Google Earth plugin of our survey. It's a topographic survey turned into a bit of a network adjustment of points that were surveyed along a dam here for the conservation area and went through the valley and a bit of a hill, so if I can kind of spin it around here, give you a bit of an appreciation for what we're looking at. So there were some open areas, some traverse went through the bush. Typically what the crew would do to start is, for example, a point over here, that would be where the instrument was set up, they would take a GPS observation here and here and here to compute the coordinates for the station, and from that point traverse on and check into other points. So moving over to STARNET here, all of the data files have been brought into a project. So there is actually a total of 4 data files, and for the purposes of the demo, I've moved most of the actual traverse network all into one to make it easier to follow. So in this data file, the first part of it contains a bunch of GPS observations. These are all RTK shots that we're taking either for resection points or on, here's a couple SSIPs, that's a survey monument or a nail. And my current adjustment, which I just ran, shows the various GPS points. One of the tricks I've learned over the years to help figure out traverses with problems is the data off switch here. So that's how, when I ran the adjustment just now, I can run it again. It's only running the data up to this point, which contains only the coordinate records of my constraining GPS points. So here's my first resection. I'm just going to simply move that, get onto there, save, and rerun the adjustment. And you can see there's the first part of the traverse. So there's my first resection. Traverse, I believe, went over to there. Then there's a check back to this point, and traverse extended over. If I take my comment, the data offline, move it down, save, and run, you can see now how my traverse is growing a little bit farther out this way, also out this way. So this is useful, I find, for projects where, for whatever reason, the traverse blows up. And by moving the data offline down, I can isolate parts of the traverse and make sure that each section grows as the project gets larger and deal with any issues that come up. So I'm going to do just kind of make things a little faster. I'm going to move that. I suppose I can delete it. I'm just going to move it to the end and save and run that again. Now for the purposes of performance, I'm going to turn the background imagery off here for now. And I'm also going to go into my settings, and I'm going to turn on the names and descriptors of the network stations. And my ellipse exaggeration, I'm intentionally going to leave right up 1. So essentially no exaggeration. So what I can see now is, as I zoom in to the traverse or to the network, I can see this, the odd point like this one over here. If I keep zooming in, I can see it's actually 2 point numbers. There's a 5266, which looks like it's a nail, and there's a 5409, which is check nail. So normally what I would do when I would discover something like this, I would go to the top of my data file and I would use these alias commands. So over here I'd say 5266 is the same as 5409. So I could put in a line here. I could say dot alias name 5266 and 5409, and that would tell STARNET that those points are the same, and work that into the adjustment. As you can guess, that's a little bit of a tedious process because I quite literally need to pan and hunt around the data looking for points that may or may not coincide and be actual points or observations on the same physical point on the ground. So it may be appropriate to use the alias or to renumber the points so that they adjust together, as in this case here. But in other cases it may not be. So it would take considerable amount of time for me to go through a project pan around. So here's a particularly busy one where it looks like there's potentially 4 points that are all on TBM or temporary benchmark that should all be the same point number so that the network would be properly adjusted. So this is the old system what I've done. I've used the alias commands. But now what I can do is use the cluster detection, which does all of that for me. So I run it with the cluster detection, and here I see point 5005 has these 3 points that are candidates for being observations to the same point. And by looking at the code and looking at the deltas, so I've got horizontal differences of 32, 25, 22 millimeters, vertical differences of 4, 0, and 13 millimeters. I'm pretty confident those should all be the same point. So I've got 4 other points here that I can quickly look at. Just expand the views. So SSIB, 11 mils, 21 mils, 5072, 5871, another good check, 7 centimeters horizontally, 13 mils, and the other 2 points are similarly 18 mils, 14 mils, 25, and 2 mils. So all I need to do at this stage is use the save and continue, and as you can see, the adjustment now has essentially done this for me and used point 5005 for all of the observations to that point, and my entire traverse now is completely adjusted. Much simpler.